Have you ever wondered where all the aliens are? It's a big question that has puzzled scientists and stargazers alike for centuries. You see, given the sheer vastness of our universe, it seems almost impossible that we're all alone. Yet, despite the high probability of extraterrestrial life, we've had no contact with any other civilizations. Not a beep, not a signal, nothing. This puzzling contradiction, this cosmic mystery that keeps us questioning and exploring, is what we call the Fermi paradox. You see, the Fermi paradox derives its name from physicist Enrico Fermi. This Italian-American scientist was known for his work on the development of the first nuclear reactor, but his legacy also includes a question that has puzzled scientists and thinkers for decades. During a casual lunch conversation with his colleagues in the summer of 1950, Fermi asked, quite out of the blue, "Where is everybody?" He wasn't referring to their fellow diners, but to extraterrestrial life. Fermi's question, now famously known as the Fermi paradox, addresses a perplexing contradiction. On one hand, we live in a universe that is incredibly vast, with estimates of over 200 billion galaxies, each potentially teeming with millions, if not billions, of stars. Around these stars, there could be planets, and on those planets, there might be conditions suitable for life as we know it. This leads us to the assumption that there should be a substantial number of civilizations out there, possibly even some that are far more technologically advanced than ours. And yet, despite our ever-increasing capabilities to explore and understand the cosmos, we have found no evidence of their existence. No signals, no signs, no visits. This silence from the universe is deafening, and it begs the question, so if there are so many potential civilizations out there, why haven't we heard from them? One possible answer to this is what we call the Great Filter. The Great Filter is a concept that suggests a wall exists somewhere along the evolutionary journey from pre-life to advanced civilization. This wall, or filter, is so challenging to overcome that it prevents nearly all life from progressing beyond it. Think of it as a cosmic obstacle course that all life must navigate and survive. It's a test of adaptability, resilience, and a little bit of luck. This could be anything from a catastrophic event, like an asteroid impact or a supernova, to a self-inflicted disaster such as a nuclear war or environmental devastation. The unsettling part of this concept is that we don't know where this filter is located in our evolutionary timeline. Have we already surpassed this great challenge, or is it ominously looming in our future? Could it be that we have passed the Great Filter, or is it ominously awaiting us in the future? Another intriguing theory is the zoo hypothesis. This fascinating concept suggests that we haven't had any contact with extraterrestrial life simply because they are purposefully avoiding us. Picture this. Imagine we are like animals in a vast cosmic zoo with advanced alien civilizations as the keepers. They observe us, study us, but they do not interfere. The premise of the zoo hypothesis is that these civilizations allow us to live in our natural habitat, developing and evolving at our own pace, without any external contamination. It's a bit like the Prime Directive from Star Trek, if you will. They may be watching, but they're maintaining a hands-off approach to avoid disrupting our societal and cultural evolution. So, the next time you gaze up at the stars, consider this. We might not be alone in the universe. We could just be part of an elaborate exhibition, our lives unfolding under the watchful eyes of cosmic observers. We could be like animals in a zoo, observed but not disturbed. Or perhaps, it's all down to the limitations of our current technology. We are, after all, a relatively young species in the grand cosmic timescale. Our technology, as advanced as it may seem to us, is but a drop in the ocean of potential scientific advancement. Consider the vastness of space, a theater of cosmic proportions. It's not just about distance, but about time. Signals from extraterrestrial life could be traveling towards us right now, but the staggering distances mean those signals might not reach us for thousands, even millions of years. Moreover, our methods of communication might be entirely obsolete in a cosmic context. We're using radio waves, but who's to say more advanced civilizations aren't using quantum entanglement or some other form of communication we have yet to discover? In essence, our technological limitations could be the cosmic equivalent of trying to catch a whisper in a hurricane. We might simply not have the means to hear the cosmic conversation yet. So, where does that leave us in our search for extraterrestrial life? We've delved into the depths of the Fermi paradox, a question that has puzzled scientists and space enthusiasts alike for the better part of a century. Named after physicist Enrico Fermi, this paradox questions why, given the immense size and age of the universe, we haven't detected any signs of extraterrestrial life. We explored the concept of the Great Filter, a potential explanation suggesting that at some point in a civilization's development, there may be a barrier or event that is hard to survive. Could it be that we've already passed this filter, or does it loom ominously in our future? The answer remains unknown. Then we ventured into the realm of the zoo hypothesis. This intriguing proposition suggests that we may be living in a galactic zoo, observed by advanced civilizations, but deliberately left undisturbed, a force much like animals in a nature reserve. Finally, we examined the limitations of our current technology, acknowledging that our ability to detect signs of life beyond our planet is still in its infancy. Our current scientific instruments and methods may simply not be advanced enough to perceive the signals that alien civilizations might be sending out. Despite these hypotheses, the truth remains elusive. The search for extraterrestrial life is an ongoing quest, a journey of discovery that pushes the boundaries of our knowledge and technology. It's a testament to our innate curiosity, our longing to understand our place in the cosmos, and the burning question, are we alone? While the Fermi paradox may not have a definitive answer yet, it continues to inspire us to look beyond our own world, to question, to explore, and to strive for discovery. The importance of this search cannot be overstated. It drives scientific advancement, expands our understanding of the universe, and challenges us to think beyond our earthly confines. The universe is vast and full of mysteries. As we unravel these mysteries, we might just stumble upon the answer to Fermi's paradox. Until then, the search continues.